my lab report for Lab 1 for Physics 2211. So the purpose of this lab was to observe and analyze the speed of a moving object at the same speed without changing its direction. And how we did this was creating an experimental graph, an experimental trial of a moving object by recording the moving object and plugging that video into Tracker, creating a computational model, and then plugging the data from the experimental model and the computational model into graphs and comparing those two graphs. This was to prove Newton's second law and the law of inertia, that when a force is not acting on an object, it will continue moving at a constant speed, and an object in motion stays in motion. And the result of this experiment in this lab proved that when a force isn't acting on an object, it will continue at a constant speed. So here's the video that we plugged into Tracker. My table in my lab group used this video of a cart moving on a supposedly frictionless track. Again, it is Earth and we are humans, so there might have been slight error and the track might have slight friction and the video might have moved a little bit, but this video was pretty close to a frictionless object in constant motion. We initially gave the object a little push to start moving, and then we used Tracker to record the data points and use the mass point graph to track the mass and create a graph in the y direction because it was moving in the y direction. So the data from Tracker gave us I plugged it into an Excel sheet and it gave us a graph that is on the top. You can see experimental position versus time, and it created a pretty linear graph showing a pretty constant velocity with a constant slope of the position versus time, and it was pretty accurate. Again, there might be slight discrepancies due to friction or human error of the cart or the video moving or human error of not tracking the mass correctly in Tracker, but it is pretty close to a very linear constant slope, showing that when the object is moving at a constant velocity like it was in the video, that it will have a net force of 0 and a constant velocity in the graph. So we used Python to code a computational model. The things that I changed from the data or from the code that was given to me was I added the velocity update formula and the position update formula using Newton's second law, and I also changed the initial velocity in the x direction. I took the y-axis in the video as the x direction in the graph to have a x-axis graph, and I changed the initial velocity using the experimental data from my video, and I took the average velocity of that mass, taking the change in position over change in time. I took the last position and the first position and subtracted that, and then over the total amount of time, found the average velocity, plugged it all in, and I got a graph, which is the bottom graph on this chart. So as you can see, that one is very constant and does not have any discrepancies because it is in a perfect computational model, but it is very close to the experimental position versus time that we did end up getting in the experimental version. So obviously there is human error. There's always going to be a slight friction in the real world. We're never going to have exactly constant velocity. There's always going to be a slight deceleration, and the experimental will never completely match the computational because of this human error of the slight video altering, but it was a pretty close match in this experiment. So what if the axes were flipped? If the x-axis was the negative x-axis in the experiment instead, the graph would have a negative slope with a constant velocity. It would basically be the same constant velocity graph with the graph going downwards having a negative slope. And if y was negative y, the graph would be unaffected because we did not use the y-axis in this experiment. So what does all this mean? Basically, all the forces acting on the object were canceling out to make the net force 0. Obviously, there's slight human error, but gravity and normal force will cancel each other out. There's no forces acting in the y direction, no acceleration in the y direction, and the constant velocity due to the initial push and force in the x direction will create a constant velocity once the force has stopped and minimal friction acting in the opposite direction of motion.